Okay, so we have looked at what momentum is, and that is that inertia of motions, depending on how much mass an object has and its velocity. But what happens if I change an object's momentum? Well, we've talked about changes in things before. We've talked about when a velocity changes or position changes. What about when momentum changes, and what might it be related to, and how can I look at it in maybe a way that combines some of our motion behavior with some of our force behavior? Well, just like any change, a change in momentum is equal to the final momentum minus the initial momentum. That's just a standard definition of change mathematically. So it's equal to the final minus the initial. Well, one way to change momentum of a single object would be to change its velocity. So that would almost be like I have mass final velocity minus the initial velocity. So the change in momentum can happen as a result of a change in velocity. And I can kind of pull those two masses out, and I end up with V final minus V initial. So this is just algebra. And that we know is defined as a change in velocity. So my change in momentum as a result of a change in velocity might be represented by looking at the mass times the change in velocity. We call a change in momentum an impulse. That is the definition of a change in momentum. Well, if a change in momentum is caused by a change in velocity, how do I get a change in velocity? What changes motion? Forces. We know that forces cause changes in motion. They cause accelerations. Now, it turns out that Newton's laws of motion were actually originally described as momentum. He looked at and studied momentum and then designed his laws of motion around momentum. So let's think about Newton's law of motion. We know that a force is equal to a mass times acceleration, right? That's Newton's second law. Well, if my force is equal to my mass, what's my definition of acceleration? Well, acceleration is change in velocity over the time that change happens. Change in time, the delta t. All right, well, if I do a little bit of rearranging, I end up with my force over the time that force is happening is equal to my mass times my change in velocity. Well, that looks familiar. This is simply equal to my impulse. So what I have is a relationship between momentum and the force that causes that change in momentum, and the force that causes that change in momentum. What I call an impulse force times the time is equal to the change in momentum. And I call that an impulse force. Whatever's causing that change in momentum, a force causes a change in momentum. So when we think about impulse, we're going to think about it in a couple of different ways. We're going to recognize that an impulse is a true change in momentum. It has to, in order for me to get a change in momentum, I have to have a force acting on that object. Something has to be changing the motion. Forces cause changes in motion. There's an interaction. So to get that change in momentum, I have to be experiencing a force. And it's experiencing that force while the force is happening. During the time that the force is happening, I get my change in momentum. So how does this relate to things we might be familiar with? Well, let's take a baseball player. If I'm a baseball player and I want to hit a home run, what do I do to help increase the chances of me hitting a home run? Well, I could hit it really hard, so I could increase my force. If I increase my force, I get a big change in the ball's velocity. I'm exerting that force through the bat on a ball. And I want that ball's velocity to go from coming at me to going away from me really, really fast. That's a big change in velocity. Not only is it a change hopefully in size and speed, but also a change in direction. So a big change in velocity. I could apply a really big force. That's one way to do it. But what does my baseball player coach tell me? Not only apply a really big force, but Follow through. Why would follow through help me? I'm only so strong. Why does it help to follow through? Well, that increases the time. If I increase the time, I'm also going to get a bigger change in momentum, a bigger impulse. So following through is all about impulse, all about increasing the time that a force is applied to get a bigger change in momentum. All right, so let's use the idea of impulse to answer some questions and see if we can determine how objects behave and do an example of impulse. And I'm going to take one of the examples in your discussion section sheet under the impulse questions, and we're just going to use this idea to determine some information. All right, so the question reads, a 0.7 kilogram ball is moving horizontally with a speed of 5 meters per second when it strikes a vertical wall. So a ball's thrown at a wall. It's moving at whatever I said it was, 5 meters per second. The ball rebounds horizontally at 2 meters per second. What is the impulse? So this is just working with our impulse relationship. Okay. Well, the first thing we want to identify is the object we care about. That's the ball. That's the ball experiencing the impulse. So, impulse is a change in momentum, which means I need a final momentum and I need an initial momentum. All right, so I need to define what is the initial situation and what is the final situation. And with momentum, that's what we're going to look at. We're going to look at what is the momentum of the object to begin with, what is the momentum of the object to end with. So we might draw a picture of the initial. That's when the ball first makes contact with the wall. It's heading in that direction, and we know that the speed of the ball, the velocity, the magnitude of the velocity, the speed, is 5 meters per second. The ball has a mass of 0.7 kilograms. The final situation after that interaction, well, here's the wall, and now the ball is leaving the wall in that direction. Well, the final velocity has a magnitude of 2 meters per second, but it's in that direction. And the mass of the ball has stayed the same. So here's my initial condition. Here's my final condition. What is my impulse? Well, impulse is the change in momentum. My final momentum is my mass times my final velocity. My initial momentum is my mass times my initial velocity. My final momentum is 0.7 times negative 2. My initial velocity is 0.7 times 5. So what is my change in momentum? Well, 0.7 times negative 2 is negative 1.4 kilograms times meters per second minus 0.7 times 5. 3.5 kilograms times meters per second. So my change in momentum is minus 1.4 minus 3.5, 4.9 kilograms times meters per second. That is my impulse. Now, that's the magnitude of the impulse is 4.9 meters per second. What does the negative tell us? The negative tells us that the force is in the leftward direction because we know that this is equal to the force times time. So the negative indicates the direction that the force is acting on the particle to cause it to have a change in momentum. All right. So impulse is simply the change in momentum. We can determine that through our force times time relationship. In this case, we didn't need to do that. Or simply our change in momentum. Both of them are valid definitions of impulse. All right, good job.